This call is now being recorded.
Okay, class, good morning. Thank you for joining my class for today. Right? As usual, this what we call this section is being recorded, and then attendance is being taken. Right? Okay. So today, for those who are eligible for the bantuan, for the 100 ringgit bantuan, you can print out the form and then you can fill the form, right? And then you can send it to us today. All right. So I've already updated the student or the family that is eligible for the bantuan lah, yeah. So if you have any problem, you can come to the school lah, yeah. Come to the school and then ask the teacher. Okay, you still remember, yeah, the bantuan one, only for the household that has income below 3,000 ringgit and below per month. Okay, so if you interested to get the 100 ringgit bantuan, the early the what we call bantuan persekolahan lah, ya, school bantuan for awal tahun 100 ringgit. So today you can fill up the form and then send the form today. Like usual lah, like macam biasa lah, ya, macam kamu ambil buku teks hari tu, just drive through only, alright? And then make sure you fill up the form, you complete the form, and then you attach required documents such as IC number, your parent IC number, and then the income slip lah, ya, slip gaji. Or if you do not have income slip, you can fill up the form and then must be signed by the ketua kampung lah, ya. Ataupun you can come to the school, or you can come to the school and then get the pengetua or the senior teacher's signature for chop lah, ya, for the stamp, right? So that is number 1. Can you hear me? Is it okay?
Yes.
Okay, good, very good. Next one. Okay, next one, number 2. For the textbook, because maybe some of you got some mistake lah, yeah. You maybe take more than one textbook, or you maybe want to change the textbook. So there are second session tomorrow at I think from, let me check first, yeah. The textbook, or you can check your what we call our Telegram channel lah, yeah. This one. Okay, tomorrow, 19 February on Friday, there are second intake, not second intake lah. You can come to the school, and then if you have mistakenly, you take extra textbook, or what if you want to change the textbook, also you can come tomorrow lah. So for Form 1, starting from 11 a.m., 11 in the morning until 12 in the afternoon, Form 1 only. If you have any question, you have any problem, you can ask me. But if you have problem also with the textbook, you accidentally take extra one, or you want to change the textbook, you can come tomorrow like usual, just going drive through only, starting from 11 a.m. To 12 p.m. tomorrow. Okay, this is for the textbook, the last section lah, yeah. But I think all 1 Alpha is already get your textbook, right? For those who got the problem, you can come tomorrow. Yeah. Today, those who are interested, and then eligible for the bantuan 100 ringgit bantuan, you can come today. Today is Tuesday, right? For the 100 ringgit. For the 100 ringgit bantuan. Starting from 8:30 to 1 p.m. lah ya. For all form peralihan until form 5. Okay. Alright. So, loud and clear? Loud and clear? Can you understand me? Is it okay?
Yes, okay.
Okay. Okay, very good. Thank you for your response. Alright. So, can we continue our lesson for today? Okay. Can you see my presentation?
Yes.
Yes.
Okay, can see my presentation. Okay, or you can open your textbook page. This is page 28. Yeah, page 28, your textbook. So today we try to continue to learn a new topic, that is 1.5, that is density. Okay, 1.5 density. Okay. For the like usual, I will tell you like this. This is just online class, yeah. If we have any practical, okay, we will do in the school after the school reopen, open back. Any practical, okay. For example, there are practical that you need to use the two measuring instrument. All right, you still remember like this. This experiment, for example, this activity, and then to learn the what? How to use Vernier Caliper. What happened here? There are so many activity, but I think we can. I will postpone the activity until you all come back to the school. For example, how to use this one, the Vernier Caliper, and then the micrometer screw gauge. Okay, this we will try to do. We will try to what we call do the activity when you come back to the school later on. Okay, because this is hand-on practical. Yeah, I cannot just explain you over the internet or online only. You need to measure it yourself so that you can get, you can understand how to measure the thickness by using the thickness or the length by using micrometer screw gauge here. All right, this one. And then another one is Vernier Caliper. This one also. Okay. The measurement, this measurement, also after the school reopen, we will do the activity here. How to use Vernier Caliper, and then how to use the micrometer screw gauge here. Because, you need to hold it, you need to measure it for yourself, then we can understand the overall concept, or overall how to measure the length or the thickness by using these two measuring instrument. Okay, when you come to the school, I will skip this one first, but in online session, I will just we will just learn about the theory or the information only, not the practical. All right, I hope you can understand. All right, I hope you can understand the situation right now, because it's very hard for us, very hard for me also, okay, to to just teach over the internet. But never mind, okay. I hope the school will be reopened soon lah, for us to do the activity like here. Okay, so we can you can skip this. I will skip this later. I will just teach you or tell you the theory, what we call the not the activity lah, not the practical side lah, but the theory side also first. Is it okay? Can you understand what I mean?
Yes.
Yes,
Okay, very
understand.
good. All right, because there is got some activity also in chapter 1, but I will skip that, and then when you come to 2, then we try to do the activity later. Okay. All right. Okay, so we continue to the next subtopic for chapter number 1, that is density. Okay, density. Right. So what you're going to learn in this topic, number 1, you must try to able to arrange the material sequentially based on their density. First, you need to know what is density, and then you can arrange the material. All right. And then predict, number 2, predict whether the material will float or sink. This is the, you must understand whether it can float or sink. For example, you can see the picture here, right? The guys here reading a book, and then it's float or sink on the water. Float or sink? The guy there, the picture, in the picture.
Float.
It float, right? Okay, it float on the water. What we call it is not sink in the water. So you must understand whether the material, the material, two different material, whether it will float or it will sink based on their density. Later on, we will try to understand. I will tell you what is density, right? Somebody want to come in? Right. Next one is to define the operational definition of density. And then number 4, to calculate the density using the formula. Okay. And using the water displacement method. Okay. Water displacement method is an activity. Also, some of the activity that we will going to do after you come to school later. Okay. Next one, to explain the phenomena related to the density difference in everyday. And then the last one, to innovate object, food or beverage using the concept of density. Okay, so this you're going to learn in topic 1.5. Okay, so number 1, you must be able to understand, you must be able to give the meaning. What is density? This one. Okay, it's density of a material. Okay, any material, any material or any substance, it has its own density. So what is the density? You must remember, density is the mass per unit volume of the material. Okay, you understand what is the mass? What is the unit of mass? Later, the previous topic, we already learned about mass. What is the unit, SI unit for mass? Anybody?
Kilogram.
Kilogram, right? The unit of mass is kilogram. Okay, and then mass is what we call the amount or the quantity of the material inside the substance, the quantity. That's why we can measure it by unit, by the what we call by kilogram. Okay, and then density is the mass per unit volume. Mass per unit volume. Okay, later we go on one by one. Right. Number 2. Number 2, you must able. Okay, number 1 is the definition of the density. You must remember mass per unit volume. Yeah, mass per unit volume. Right. So the second one is the formula of density. Right. The formula of density. You must what we call understand the formula. This formula, so density is equal to mass over volume over mass. Okay, so what is the unit for mass? The unit of mass in the formula is gram. Okay, the unit is the gram, and then the volume is centimeter cubic. The volume, the volume is centimeter cubic, and then you volume over mass, and then you get the density, and we call this gram per centimeter cubic. This is the density. All right. Or you can easily remember the formula by remember the triangle used for the formula that relate density, mass, and volume. Okay. Meaning this, if you want to find the density, the first formula, if you want to find the density, meaning that you must divide volume over mass. Okay, what is the unit of mass in the formula? The unit of mass is what? Anybody?
Kilogram.
Yes, I cannot hear you, but never mind. The unit of mass is gram. Make sure it is gram. And then what is the unit of volume? Volume is centimeter. Centimeter what? Centimeter cubic. The three, the number 3 after the centimeter, we call it centimeter cubic. The volume of the material. Okay, volume of the material. So you get density. So the unit for density is gram per centimeter cubic. Okay. So if I ask you to find the mass, so what you need to do? According to the triangle here. According to the triangle here, if given mass, you need to, if given density and given the volume, so how you want to do it? Mass is equal to what? If you want to find the mass given density and volume, meaning that density, you must multiply it with volume. Can you understand this? Can you understand the formula equation? The formula here? Okay. Because it is easier for you to remember by doing using the triangle here. If you want to find the volume, can or no to find the volume? Also, we can find the volume. Volume mean mass. You divided by density. Density. Okay. If you want to find the density, that equal to, if you want to find the density, mass over volume. Yeah, like this. We can conclude all of this formula by using a triangle, by just doing a triangle. But you must have either two of the value lah. You must, for example, maybe you have density and volume, so you can find the mass. Or you already get the volume and mass, you can get the density. One of the value, you must obtain one of the two of the value in the formula, then you can find the others value by using the formula here, right? This is very easy. Later on, we try to do the calculation. Yeah. Okay. Next one, activity 1.10. This is also activity in the lab, but I will try to explain for you first. Yeah. Okay. The activity here, we try to what we call find the density of the. We try to find the density of the material here. How many material here? There are 4 material, right? There are copper. Okay. There are copper. There are iron. This is copper, iron, cork, and wood. There are 4 type of material. Okay. And then this all material has the same volume. How do you want to find the volume? Regular object volume. Volume meaning that you must multiply the what? This is the height, and then this is the, what is this? The height, the width, and the
Length.
The length, yeah? The height, the width, and the length. All right, you must multiply all these three in order to get the volume. For example, I take copper, yeah? If the copper, the height of the copper is 1 cm. I take the copper for example, yeah? And then also 450. The width of the copper is also 1 centimeter. Can you follow me? Can you understand this?
Yes.
Okay, and then also the what we call the width of the copper is also 1 centimeter. Okay, also 1 centimeter. So can you find the volume of the copper? Can you find the volume of the copper?
1 centimeter cubic.
Okay, so yes, very good. It's correct. So if you want to find the volume of regular object, this is regular object, yeah, because we know that the height of the object, the height of the material is 1 centimeter. Copper also the width also 1 centimeter, and then the length also 1 centimeter. So you just multiply it all, 1 times 1 times 1, so you will get 1 centimeter. Centimeter what? Centimeter
Cubic.
cubic. Yes, 1 centimeter cubic of volume. So very easy lah, because this is the regular object. Okay, you just multiply height, width, and their length. So you will get the volume. Okay, you will get the volume. Right. According to the, we continue, yeah. According to the instruction here, all 4 cube has the same volume. Okay, all 4 cube has same volume, meaning that iron is also, what's the volume of iron? The volume of iron also 1 centimeter cubic. Cork also 1 centimeter cubic, and then wood also 1 centimeter cubic. So do you have the volume for all of the material? Right, we already we already obtained the volume of the material. Copper 1 centimeter, all copper, iron, cork, and wood all has 1 centimeter cubic of what? Of volume. Okay. Number 2, how do you want to get the mass? Mass here. How do you want to get it?
Density times volume.
Hello? You must use what? You must use?
Density times
You must use what is the instrument? What we call the measuring instrument to measure the mass. You can use, what's the instrument? You can use digital balance, all right, in order to get the mass, right? So I just give you example only. I just give you the what we call the estimate mass of the object here. Wait for me, just wait for a moment. I will try to get the mass here. Okay. You need to measure the mass by using what? By using digital balance or a triple beam balance or the lever balance. You still remember the measurement, the measuring instrument for measuring mass? Okay, whether you use triple beam balance or lever balance or digital balance. Okay, so I will just give you the balance first. For example, copper here, right? This is just an example only. if I measure the mass of the copper, it is about maybe about 24 gram. Okay, how do I get this figure? How do I get this figure 24 gram? After I measure it by using digital balance. Okay, kita nak tahu dia punya berat dia berapa. Okay, but never mind. After the school open, we try to do the experiment again. I just want to explain you how you get the density first. Okay. When I try to measure the mass of the copper, I get 24 gram. Okay. How about iron? Maybe after I measure it, I get 20 gram. And then how about what happened here? Okay, for iron, maybe I get 20 gram. Okay. How about cork? Cork, maybe I will get only 10 gram. And then how about the volume of wood? Wood, maybe I will get about 18 gram. 18 gram. So do you follow me? Can you understand me? Where do I get the figure here? 24 gram, 20 gram, 10 gram? After I measure it by using digital balance. Okay, because different material has different mass. Okay, different material has different mass here. So how do I get the figure? For copper, 24 gram. For iron, 20 gram. For cork, maybe I get 10 gram only, but wood, 18 gram. Maybe I will change it lah to not 18 lah. Maybe this one I will just 6 gram, and then this one maybe about 10 gram. Okay, so how do I obtain the value here? After you measure it by using digital balance, so you will get the mass of the material or mass of the object here. Because different, again I said, different material has different mass. Okay, different material has different mass. So what information I already obtained, right? The information I already obtained here is the mass, and then also the volume. Volume I also obtained. So you can use the value here to get the density. Okay, what is the density of the copper? Anybody? For example, I give you one example here. I take copper first. I will take the copper first. So what is the mass of the copper? The mass of the copper is how many? 24 gram. And then what is the volume of the copper? Volume is 1 centimeter cubic. Right. So the answer is for copper, for density of the copper. Okay. So what is the density of the copper?
24.
24 cubic. 24 gram per centimeter cubic. So this is density of the copper. The density of the copper. And then you can use the same calculation for all other material, iron, cork, and wood. Okay, because the volume is same volume, because all the material volume is the same, so iron density is 20 gram per centimeter cubic, right? Cork is 6 gram per centimeter cubic, and then wood is 10 gram per centimeter cubic. This is just example only. You need to get the accurate mass of the object by using digital balance. Okay, this one I just give you the figure only. Maybe the figure only. All right, maybe sample only lah. Okay, so what happened? I give you another example. If I use an object, that is still a regular object, still regular object. This is the object, still regular object, but the object here is 2 centimeter times 2 centimeter times 2 centimeter. Okay, the width of the object is 2 centimeter, the length of the object is 2 centimeter, and then the height of the object is also 2 centimeter. So what is the volume of the next object? This object?
8 centimeters.
So how do you get 8 centimeter? You just multiply 2 times 2 times 2. Right? So you multiply all this together. So you got 8 centimeter cubic of volume. Okay. So you just change here. You just what we call replace the value lah, because, and then maybe I measure the object here, and then its weight, and then I try to measure the mass. Its weight about maybe 12 gram. Okay, this is for another. This is for other material. I'll try to weight the object here, and then the mass is 12 gram. So how do you want to calculate it? So same thing, by using the same formula. What is the mass of this object? I call it object Z. Object Z. So the density of Z is, where's the mass? 12, right?
Gram.
That's right. Okay, 12 what? 12 gram. And then you divide it by how many volume?
8 centimeter cubic.
8 centimeter cubic. So what is the answer?
1.5.
1.5. Is it true, class?
No.
What is the answer? You multiply it. So you divide it. Where's the answer? 1.5 gram. Is it true, right? Betul lah. 1.5 gram per cubic centimeter. This is how you find the density. Okay, this is how you find the density. Yes, the answer is 1.5. Thank you, Mr. Yep. Right, 1.5 gram per centimeter cubic. Can you understand how to find the density? Any problem?
Yes.
Okay, very good. So you must need at least two value, whether it is density, mass, or volume, so you can get the other value also, right? This one later lah. I need you to understand it first. Okay, next one. Can you see the table 1.4? Table 1.4 is the density of various material. They already what we call calculate the density, and then this is the density of the material they already obtained. For example, okay, I will zoom it for you. The density of gold is about 19.3 gram per centimeter cubic. Okay, with the same volume, meaning here same volume, but the same volume of the material. The only difference is they got what we call different mass. So same volume, different mass. So this is their density. Lead is about 11.3 gram per centimeter cubic. Okay. If I try to ask you, compare gold and lead, which one has higher density, gold or lead? Which one has higher density? Yes? Okay. Yes, of course, based on the table here, gold has higher density than lead, because gold 19.3, lead 11, lead is 11.3. Okay, meaning that the density is higher. When the number of density is higher, meaning that density is also higher, right? Okay, this one is very important. The density of pure water at 40 degrees Celsius is 1 gram per centimeter cubic. Okay. If I compare, I will ask you again, you try to compare between the density of water and then the density of cork here. Which one has higher density?
Water.
Which one has higher density? Cork or water? Which one has higher density? Water has higher density than cork, right? This one. It much higher. So what happened to the cork when I put it on the water? What happened to the cork here? See, it will float, because water has what? Water is 1 gram per centimeter cubic. Cork is about 0.24. So because the density of the cork is less than water, so the object will float. If the density of the object is more than water, for example, copper here, the density is 8.9. And then the water density is 1 gram per centimeter cubic. So the copper will sink in the water because of the density, different density. You must understand this, because this is also a very popular question we'll ask you. Okay, again here, petrol, because the density is lower than water, it will float on the water. But mercury is much higher, the density is higher than water, and petrol, it will sink at the bottom. This is the liquid, petrol, water, and mercury is liquid. So my question is, if I put copper inside the beaker here, beaker A, beaker A here, if I put copper, all right? Sorry, if I put copper here, where is the position of the copper, you think? Okay, is it in
And mercury.
Okay, wait. X, Y. Sorry. Is it in X? Is it in X, Y, or Z? If I put copper.
Y.
Okay, if I put copper, it will be, the position of the copper should be at Y. Okay, correct. Very good. Because why? You must go back, look back at the density of the copper. Density of copper is how much? 8.92, right? So density of the mercury is 13.6. So the density of mercury is more than copper, so it will float on the mercury. But it will sink in the water, and then will sink in the petrol. Is it okay? Boleh faham ini ya?
Yes.
Okay, very good. This is what we call the concept of density. Okay, you must able to identify which material has higher density, and then the position of the object when you put inside the beaker, for example, it will float or it will sink based on the density. And then also you must be able to calculate the density by obtaining the mass of the object and then the volume of the object, right? Okay, again here, This is what we call the arrangement, what we call the arrangement of the density here lah. Mercury, because mercury, the density of mercury is more than copper, it will sink in the bottom, at the bottom. Okay, copper, water, ice, petrol, and cork. Meaning here, the density of the cork is much lower. The density of the cork is much lower than everything else. Okay, can you understand this? Based on the density, right? Okay, next one. Calculation of density by using formula. Okay, this one. Actually, this one you need to do in the lab for you to easier for you to understand. But never mind. All right. So how to measure the density for irregular object? How to take the density using irregular object? Last time, I'm using regular object, right? Regular object mean, for example, last time copper. Copper is 1 centimeter height. The width is 1 centimeter, and then the length also 1 centimeter. Very easy for you to calculate the volume, right? So 1 times 1 times 1 is equal to 1 centimeter cubic. But how about if you want to measure the volume of irregular objects such as the stone here? We cannot measure the stone by simply using the ruler because it is irregular. It is not just the cube. Cube very irregular, right? Cube you can measure by using a ruler. 1 centimeter times 1 centimeter times 1 centimeter, and then you get the volume. So we are using what we call a water displacement method by using measuring cylinder. Okay, we want to find the volume, right? We want to find the volume. Find the mass, no problem. You just weight the stone. You use the digital balance, and then you will get the mass. But how to find the volume? This is how you find the volume. First, you put the water inside the cylinder. First, you put water into the measuring cylinder, and then you take the initial reading. For example, the initial reading here is 50 milliliter. But you need to remember this first. You need to remember this first. Okay, this is last subject. You bear with me. 1 centimeter cubic is equal to 1 milliliter. Okay. Maybe you ask me how we are using centimeter cubic, right? So in measuring cylinder, you use milliliter. So what is the conversion? This is the conversion. 1 centimeter cubic is equal to 1 milliliter. Where is the symbol? The symbol is 0179. Okay. 0179. Okay. You understand this? This is the conversion first. 1 centimeter cubic is equal to 1 milliliter, because in measuring cylinder, what is the unit for measuring cylinder? The unit for measuring cylinder, we use what? Class? We use milliliter. Are you with me? Still with me?
Yes.
Yes.
Okay, good. So, okay, thank you. So for initial reading, initial mean at the beginning. Initial mean the starting at the beginning of the what we call the reading. So you have 50 milliliter, right? Then what you want to do, you put the stone, you tie the stone with the string, and then you lower the stone inside the measuring cylinder. What happened to the water inside the measuring cylinder after you put the stone inside? What happened to the water? The water level, what happened to the water level? When
The
you
water level goes up.
Yes, very good. The water level will goes up. Okay, the water level will goes up. This is what we call a water displacement method, meaning that the stone is already displaced the water inside the measuring cylinder. dia menggantikan ya. So the water level will rise up. And then what happened when the water rise up? So you take the final reading here. Okay, you take the final reading here. The final reading, for example lah, maybe all right. The final reading is depend on the size of the stone. If the size of the stone is bigger, maybe the final reading or the water will raise up more. Okay, so I just give you example only, just sample only. Maybe after you put the stone, yeah, the final reading is maybe about 56. It will raise about, not 56 lah, about 62 centimeter. No, not centimeter, sorry. It will raise about 62 milliliter. So, can you find the volume of the stone right now?
12 cm.
Yes. So you will able or not able to find the volume of the stone right now?
Able.
Yes, you're able to find the volume, right? So how do you want to find the volume? So initial reading, final reading, you minus 2, initial reading. Yeah. So final reading minus initial reading. So final reading is how many? 62 milliliter. You just minus by 50, and then you will get what?
12
ml. Yes, ml. So you got 12 milliliter or 12 centimeter
cubic.
Huh? Or 12 centimeter cubic. So you already get the volume for irregular object. So after you get the volume for irregular object, you can continue to calculate the density. Okay, how to find the mass? How to find the mass of the stone? You use what? Untuk cari berat dia. Untuk cari berat batu ni, untuk mencari jirim batu, you use measuring apa? Digital balance. And then you find digital balance. Maybe the digital balance, the mass may be about, after you measure it, the mass of the stone is maybe about 52 gram. Contoh sajalah ya, this is just sample only ya. So after you measure the mass, you using the balance, using the digital balance, you find that the mass of the stone is 52 gram. Right. So can you find the density of the stone right now? Can you find the density of the stone?
Yes.
Yes. How you want to find the density of the stone? Meaning that the density must be equal to mass over volume, right? So what is the density right now? Sorry, density, you don't know the density, right? We do not know the density. So what is the value of the mass? How many?
The volume is
No. The mass volume, the value of the mass right now. How many? Here?
52 grams.
52, right? 52. And then you divide it by the volume. What's the volume? 52 gram. You divide by 12 centimeter
Cubic.
of volume. So you will get, what is the answer for density right now? So the density is 52. 4.33 lah, 4.33 something gram per centimeter 0.10 cubic. This is the density of the stone. Okay, Can you understand this? How to take the density for irregular object. This is for irregular object. Okay. Okay. Any question?
No.
Okay. Never mind. After the school open, we try to do the activity. You just understand how the concept first. Yeah. You try to understand the concept first. Okay. So we stop right here. Now it's 9:53 a.m. So I stop here. For the exercise for today, you open your workbook and then you try to do the question numbers 8, 7, and 8. Question number 7 and 8 for chapter 1. Okay? Question number 7 and question number 8. Question number 8 is the question that we just learned right now. Okay? Is it okay?
Yes.
Later on, I will try. I will give the exercise. Which exercise I will give on the Telegram group lah. Yeah. Any question before we stop here?
No.
No question. Yeah. Okay. Very good. So where is the right? So how many today? 28. Okay. Very good. Here presenting. So I will stop here. So we will meet again next week, same time, same time, and then same day. If the timetable is not changed yet, yeah. Because I think starting from next week there is a changes in timetable. But if I have anything change, I will inform you in our Telegram group. Yeah. Any changes, I will inform you guys. All right. So if there is no other further question, I think we can end the class right now. So I'll thank you for attending my class. So you can leave the class right now. Thank you very much. We see you all again next week. Okay, bye-bye.
Oh, why no
Thank
question?
Yes, sir.
Thank you,
Yes,
teacher.
Yes, sir.
thank you. All right,
Thank you, teacher.
thank you. Bye-bye.